Good afternoon, everyone, and welcome to the Re-Tool Tour 2020. We are in Anaheim, California at our showroom at Expo West. We call it Weinig Holz-Her Expo West because it's on the West Coast. Our main showroom is in Mooresville, North Carolina, and this is our West Coast showroom. We are in Anaheim, California, right down the street from Disney. It is a great day here. We are in day number 5 of the Re-Tool Tour, which has just been an absolutely great event. I've been so happy to take part in this and just see all the different showrooms across the entire country, that we have so much technology in every region of the U.S. It's absolutely incredible. Big shout out to all of the agents out there who covered Weinig Holz-Her in all the different areas of the U.S., especially those who were part of this week's Re-Tool Tour. So big thank you. We couldn't have done it without you. You guys are awesome. Everyone out there watching, if you're a small shop owner, if you're in a large cabinet corporation, whoever you may be, we appreciate you watching. This is a live video, so drop your comments in the comments feed down there, and we'll get them answered for you. Tell us where you're watching from. Let us know who you are. And if we can be of any service to you guys, if you see anything that you're interested in or you have questions about, just reach out to your local Weinig or Holz-Her sales guy, and they'll be able to help you out. So, like I said, we're at Expo West. We are actually doing the last demo of the day here, which means this is actually the last demo of the entire Re-Tool Tour of 2020. It's kind of fitting. I think it's kind of fitting that we're bringing it all the way back to just absolutely excellent Weinig profiling technology. We're going to be talking about HSK tooling for the next 45 minutes or so, and to help us out with that, I want to bring in Matt Wecker, who's our regional sales manager in the Western region. Hi, Matt, how you doing?
Good, how are you?
Good. So I'm going to let Matt kind of frame up the demo, and then we'll get started.
Happy to be here. Matt Wecker with Weinig West, and Daryl Kinsler, also with Weinig, and we're going to be walking you through HSK Technology, how it was developed, why it was developed, how it's different from some traditional technology that we've had on molders in the past. And then we're going to be running a PowerMat 700, which is outfitted with tools that are half spindles and half HSK spindles. So it's going to be a good contrast between the conventional technology that maybe most molders have and the new technology that's over the past decade or a little bit longer with HSK tools. So I'd like to start by showing you the 3 basic types of tools that you're going to put on a molder. And so let's walk over here. Let's get started. Let me show you some examples of some tools. We've got our grinder that we'll go through in a moment. This grinder has an HSK tool holder on it. We can put a spindle extension on it to grind conventional tools. We have our measuring stand that measures radially like a feeler gauge would, but it also measures axially, and it measures within the thousandth. And we'll go into this technology, this measurement, what it means with the system, and how everything kind of operates together. So if you look at the table here, and Christian, maybe you can zoom in a little bit. I set out some examples of 3 different types of tools. And so the first type of tool that maybe most folks are most familiar with is conventional tools. And when I say conventional, there's a bore in the middle. On a lot of molders, that might be an 1.5 inch bore or an 1 13/16 bore. So that's the size of the spindle. And so we take this head and we slide it on the spindle. Daryl, can you do that? Can you take a head and slide it on a spindle and show everybody what we're talking about? So Daryl's opening up the door for the first top spindle, and he's sliding an insert head onto that top spindle. Now, as with every conventional tool, we have a spindle nut that we have to tighten on the end of the spindle. And so that's what Daryl's doing. So we have some cool technology that saves your knuckles, and it's called a servo lock wrench. And so this works on all of our standard tooling machine, even our older machines. And Daryl, you want to just tell everybody what you're doing?
Okay, so what I'm doing here, I'm just aligning this tool up to the spindle and the nut. From there, if you look here on the tool, I've got an arrow going this direction for rotation that tells me that I'm locking that on there. So I'm doing that until I hear it click 3 times, and I'm backing it off, and it's tight.
Okay, so did everybody get a good look at that? So we're going to go back to this molder here in just a minute. But the next technology of tools that we see on molders, and this technology has been around for quite some time, is Hydrotools. And so right here, this is an old Hydrotool. This is a good example. And it has a zerk here that you fill with grease. And when you pump up this tool with grease, there's chambers inside this tool. And when you pump it up with 300 bar, 300 atmospheres, what that does is it grabs, the tool grabs around the spindle 360 degrees. So we have a higher degree of accuracy on this tool than we do on conventional tools. The mere fact that we can slide a conventional tool or even a hydro tool on a spindle means that there's slop, there's tolerances there that that it's not the perfect fit. So that's how we get around that with this tool. And so this tool we use with joining applications. And I don't want to go into that too much because that's not what this presentation is about. But with jointed molders, we have, if you notice, we have 1, 2, 3, 4, 5, 6 knives in this head. And so there's a point from the center of the tool out to the end of my finger. If every single knife is microscopically that same point to the end of my finger, then you'll see that knife on the finish of your wood. But it has to be within 7 microns. And so I'll go and talk about what that means, how big of a unit it is, in just a minute. But if we are within 7 microns of the projection of the knife that's sticking out, each knife will be a finished knife on the material, and we can speed the feed speed of the molder up ×6 on this head, or ×4 on a 4-knife head. So on a 4-knife head, if we're running 30 feet a minute, we're going to run at 120 feet a minute. 6-knife head, 180 feet a minute. Okay, so that's a little bit about that. And then the third type is the type that I'd like to focus in on, and that's HSK tooling. And so, Daryl, do you want to put an HSK tool on the molder as well? Okay.
So right now, I'm just hitting the button here. What that's doing is unlocking the clamping unit. Once it's unlocked, it will release the cutter head, or anything that you have in there. And then now, if you guys look, you can see the open void here if you can get in there and get a shot of that. And if you notice right now, these fingers are retracted. But when I put this in and I actually hit that button again, those fingers are going to come out and they're going to fulfill this cone. And then that's going to give it a perfect fit.
So it's an expanding collet with fingers that expand out 360 degrees, and it's grabbing the inside of the flange and pulling that HSK tool on to the tool holder. So Daryl's gonna take the head off and do it again. Now the head is releasing, the collet is retracting, the head is free. So the fingers go into the HSK, and there's a little ridge right here where they expand and then they pull back. And then that creates a seat on this shoulder of 2 tons of pressure. So a little easier to change a head on an HSK tool, a little bit quicker. Okay, so let's go back over here and talk about the HSK tool. There's 5 fundamental advantages to using an HSK head, and their accuracy, faster tool changes, what you saw over there, the clamping force, the rigidity of the connection to the molder, and no outboard bearings are required. So we don't have an example of a 12-inch tool, but if we wanted this tool to be 12 inches tall and we had a 12-inch HSK molder, which we do make, which we do produce, which we do sell, that HSK tool would just be held on with the HSK connection with no outboard bearing. So I wanted to explain a little bit about how the HSK tool is being held on to the tool holder. And this would be indicative of on a molding application or on a CNC routing application. HSK is used in the automotive industry, lots of other larger industries. So again, we have a collet that comes into the center of the taper here, and like I said, they expand out from the inside, and then we also have force going on this top ridge of the tool, and force on the outside of this as well. So all those forces, the inside and the outside forces combine. And it's what I call a 0-to-0 setting system. So, okay, so HSK, why are we calling it HSK? Why was it developed? Bodo, can you say this word, please?
That is a German word for HSK, Hole, Shaft, Kegel.
Okay. So basically what it means in English is hollow, taper, shank. I'd rather call it quick lock center position tooling. But what I tried to diagram here is the force from the outside, where you see it's on the outside of the shank, and then on the face of the, and then on the face of the HSK here, and then again the collet expanding and the force on the inside as well. So we happen to have HSK 85. So that's classified by measuring the distance of the tool at 85 millimeter. Some CNC routers have HSK 63. There's different sizes and different types of HSK based on the application that you need it for. There's smaller diameter HSK for applications that maybe require less torque and less power. Maybe we're milling plastic or some lighter materials. We needed to be on the a little bit larger of the size of HSK because we needed the torque, we needed the rigidity. Some of the spindles some of the horizontal spindles that we have with HSK might be 30, 40, 50 horsepower. So we need to be able to have that rigidity and that clamping force for those horsepowers. So do you think that we could run a stick and show everybody the finish of an HSK? Sure. And then I think what we'll do is maybe we'll run another stick. We'll bring that head up, that HSK head up, and run another stick with conventional tools. Sure. And let's compare the finish on those two sticks. Let's try. Okay, sounds good. Okay. Yep. Please turn on the dust collector. Okay. The first one's going to be conventional. Okay. So we're going to run a first stick, and it's going to be with a conventional tool. And so while he's setting this up, if you can still hear me, I wanted to talk about the differences in accuracy of each type of tooling. So we talk about thousandths in our industry for our applications, and you can see we're 0.05 millimeters and 2 thousandths of tolerance on a conventional tool. We're 10 times more accurate on a hydro tool. And so we're 1/5 of a thousandth. And then on the power lock, we're 1/3 of a thousandth, 0.003 millimeters. But in my mind, I think that it's easier for me to grasp the accuracy when we talk about microns. On a conventional tool, we're 50 microns. On a hydro tool, we're 5 microns. And on a power lock, we're 3 microns. To give you an idea of how big 3 microns is, it's the size of a bacteria. So that's the size of 3 microns. What's the size of 50 microns? That's the size of a human hair. So going back to the physics of a good finish on a molder, it's the projection of how far this knife sticks out in relation to all the other knives on the head. And if microscopically within 7 microns, their intolerance, each of these knives are going to be showing a knife mark on your material. If we're even out 12 thousandths, there's going to be one knife showing, and the other knife is just going to be doing the hogging. Okay. So Daryl, what are you doing?
We're just pushing the boards through at the moment, and then at the end I'll pull them out and you guys can see the finish of a conventional tool.
So it's kind of hard to hear right now, but we've got wood going through the molder, and it's getting spit out the other side. Okay, so Daryl's shutting down the machine right now. We've run 2 sticks with a conventional tool. And now Daryl's going to apply some Ebony Stain on here. And what that's going to do is that's going to show us the knife marks that the machine has created and give us a good idea of finish quality. Nice job, Daryl. Nice even coat there. And so I don't know how well you guys can see that on the camera, but look at how the board is shining off some light, and you can probably get a glimpse of the knife marks that are on the board. those knife marks look like they're probably about 1.5 millimeters apart from each other, which would probably be around 14, 15 knife marks per inch. So that's kind of what we shot for, and we determined that based on the RPM of the spindles, the feed speed, and then the number of knives in the cutting tool. Okay.
Make some adjustments, and then we'll do the HSK tool.
Fantastic. So this is a quick changeover machine, and we're going to change it over quickly, and we're going to run a couple of sticks off the HSK head, off the top HSK head. So what Daryl's doing right now is he's adjusting the first top head out of the way, so he's moving it up radially, and then he'll be adjusting the second top head, head number 5, and he'll be moving that down and into position based on the thickness of the piece that we're spitting out. So right now, if you see, this isn't a presentation on PowerCom software, but the machine is moving into position. Any of the motorized positioning of the molder will happen simultaneously. So if you have a feed beam, if you have a top spindle, if you have a right spindle, when we acknowledge that we have the right heads on the machine, those motorized positions will position simultaneously. So we're starting up one head at a time. Daryl's listening for each head to cycle in, and then he'll move on to the next head. Okay, we got all 5 heads fired up, 6 heads fired up. Fantastic. All right, so now Daryl's going to apply some Ebony Stain to the profile that has been run with the HSK head. And again, this is a difference in accuracy of between 50 of what we have on a conventional tool and 3 on what we have on this HSK tool. So the HSK diameter of the tool is a little bit smaller than the diameter of a conventional tool, and the knives scoop into the material a little more shallow. And so you can probably see the difference, the slight difference in finish quality between the HSK head and the conventional head. Okay, so we talked a little bit about the accuracy of HSK, 3 versus 50. What is it that you need if you were to jump in and have an HSK molder? I know that there's been a little bit of confusion about what are the other things that are necessary to be able to set up the molder, run the molder, measure the tools, grind the tools. So what I wanted to do is show you the grinder and the measuring stand, which is all kind of part of the HSK molding system. And so, Daryl, can you show a customer how to grind a conventional tool if you have this new HSK grinder. Just put the tool on the head.
Just put the tool on the head?
Yeah.
Okay. All right, so in this grinder right now, I've got an HSK tool set up, so I will walk over and get a conventional tool for you. From there, it's really very basic and very simple as far as how to install these and remove these. But if you look here, similar to what's in the Moulder, we've got the same HSK collet, okay? We also have a little bolt in here that will allow us to open and close the HSK fingers and cause the separation there. When that separation happens, I am able to extract the collet, the tool, okay? And if you look in here, the fingers and the way that it's developed is the exact same way as it is in the machine. All right, so if we go from a standard HSK head to what we would classify as a board tool or a conventional tool, we've got to use an adapter. And the adapter that's needed is actually an 1.5 inch diameter adapter for a cutter head. But from there, it'll go on the same, we'll lock it in, and then we'll grind just the same. The big difference in between grinding a conventional cutter head and an HSK cutter head, again, is the diameter of the cutter head. So if we have the assumption that we can use tools or knife stock that is in a conventional cutter head in an HSK cutter head, that's false. We have to regrind all of our conventional stuff to meet the diameter of the HSK, or vice versa. If not, then our clearance angles and the angles that we grind our cutter head on will not match up and be the same.
Okay, thanks, Daryl. So if we buy a brand new Weinig Rondomat 960 grinder, we can just as easily grind our HSK tools as we can our conventional tools. A lot of folks that jump in and buy an HSK Moulder might use it as a 1-2 punch. Maybe they have a jointed machine that runs Hydrotools. Maybe they have an old Profimat that they had, from 20 years ago that they still run S4S on. You can grind all those tools with this new grinder. Just stick that spindle extension in. So, and then same goes with the measuring stand. So if you have Moulders, and some of them are, maybe it's a Profimat P23E from 1992, and it has 1.5 inch spindles. We put the 1.5 inch spindle extension in, but then you've got a U23 with 1.13 inch spindles. You put that 1.13 inch in there as well. So the beauty of a measuring stand, an OptiControl measuring stand, is that you can measure to within the thousandth. And so, Christian, if you could pan in and if we could see this graduated scope here, this kind of shows you the accuracy, 26 times the magnification. And as it's compared with like a feeler gauge stand that some folks use, it's going to measure those peaks and valleys and corners more accurately. And so if you have an accurate Moulder, you're going to want an accurate way to measure the tool. And if you have accurate tools, you're going to want to stay accurate throughout the entire molding system. So a Moulder the molding application is an application of accuracy. And so when you need to replace your Moulder, you're probably replacing it because you're not accurate anymore. And so the grinder goes out of tolerance. The bearings go out of tolerance. Obviously the Moulder starts to loosen. And then if you don't know where you are on the measuring stand, you don't really have an accurate application. You run a lot of test pieces. So when we talk about HSK tools and we talk about 3 microns of tolerance, we also want to talk about these other machines as well, because it's all part of the system. And that's what creates a finish that you see from that HSK head. So it all translates to finish quality. So again, the things that the things that an HSK tool does for the fella that uses it is it's a high degree of accuracy, a high tolerance, very quick and easy setups, and no outboard bearings for 12-inch applications. Also, we can speed the spindle speed up on an HSK. So in the past, our speed limit was about 8,000 RPM. So we have some machines that we've made over the years that have gone up to about 8,000 RPM. But that's about as fast as we could go with the limits of the conventional tools. And so now, because that lock, that connection is so accurate, we can spin at 12,000 RPM. So most molders have about 6,000 RPM. So right then and there, we can increase our throughput twofold. So there's some usefulness and some utility in that. And then also the way that we set up our molders now, and I don't want to go too much into it because it's about HSK, but what we're doing is we're taking the measurement of the tool and we're putting it in this computer here that's sitting next to the tool stand. And that measurement is going inside of a tool in a tool library, and that tool is a conglomeration of tools in a profile library. So if we know that we're measuring this tool for Irish 5, and we know that the height of Irish 5 is 3/4 of an inch, and the width of Irish 5 is 4 inches, then we've already done 80% of the math that we're expecting the molder operator to redundantly do at the molder. So let's take this information and then let's beam it out on a wire to our PowerMat 700, and then we have our molder operator, let's say he follows directions more than setting up the molder, doing test pieces, doing straight edges, tribal knowledge, taking lash out of spindles. And so let's have him follow the directions. Let's put motors on positions for axial and radial positions on spindles or tool holders. And let's have all of those motorized positions move simultaneously. And what that does is it makes the molder operator responsible for now about 20% of the adjustments that he's had to been responsible for in the past. And if he's doing 20% of the adjustments, logic would tell you that his setup time is going to be about 20% of the setup time that it was in the past. So that's a little bit about the system. So basically, we view HSK as something that was very beneficial for us, very beneficial for our customers because of the accuracy, because of the speeds, because of the convenience, and I would say now, Daryl, what do you think about at least 40% of the molders that we sell nowadays have HSK tools on them?
Yeah, the 40% number is probably close to accurate. It depends on the type of customer that we're dealing with. In cabinet shops and in window shops, different things like that, a lot of customers do many changeovers throughout the day with short runs. If they're averaging 100 to 500 feet per run, it's beneficial and almost necessary in this day and age to utilize a PowerMat machine.
Let's open the hood of the PowerMat 700 one more time, and let's look inside this particular machine. So when you said cabinet shop, it kind of dawned on me that this configuration of this particular machine is really made for a cabinet shop. So like I was saying in the beginning of the presentation, we outfitted this machine with half conventional tools and half HSK tools. And so why did we do that? Well, we wanted to put the HSK tools on the on the spindles that we thought that the customer would be changing the most. And so if it's a cabinet shop application and he's doing stiles and rails and face frame, he's changing over his top head quite a bit. And he's changing over his vertical spindles, his left and his right quite a bit. So let's put HSK on those. So again, we have HSK on this spindle, 3 microns of tolerance. We have a conventional tool on this head, 50 microns of tolerance. So the reason why we put HSK on the second spindle and put conventional tools on the top spindle is if this is the last spindle that's going to be doing the work, then why not save a little bit of money on the first spindle? Also, we have conventional tools on the bottom spindles. We're not going to be doing as much changeover on that. So save some money on the bottom tools. So this is an example of a machine that uses both types of technology, and it can be beneficial. And you can still grind tools as easy one way or the other, conventional or HSK. And so we see customers, especially customers that are making cabinets, use this configuration on this machine. So, yeah, I mean, I think that's basically what I wanted to cover regarding HSK tools. Try to remember 3 microns versus 50 microns. And that's your difference in tolerance. So thanks, guys, for joining us. We really appreciate you guys. Those of you who have been spending the week watching some of our videos, thank you for your attention and thank you for your support. Christian, you want to take it over from here?
All right, I'm not Christian.
Oh, you're not Christian.
Thanks, Matt. Thanks, Daryl, for taking us through this walkthrough of all the different things, all the different ways to put tools into molders. We're going to start. If you keep up with some of the things we've done in Mooresville leading up to this week, we started calling Dan Hirschberger the professor. I think we might have another professor on our hands with Matt and all of the explanations that he had. All right, so we're not only done with this presentation, but this is the last presentation of the Re-Tool Tour. So just to give you a bit of a wrap-up, we've gone from Miami to Mooresville. Then these guys went to Michigan, and I went to Hickory. And then we all met again in Salt Lake City, and then now we're in California. Of course, we had challenges along the way. We had a lot of fun along the way. And today we've had the most challenges where we first struggled with Wi-Fi, which is why you're watching this late at night instead of live. I did promise when I went live on Instagram earlier, if you guys were watching, I did tell you that it's going to be live footage. We're not doing retakes or anything like that. We told everybody that we wanted it to be as real as possible when it goes live. But not only that, we're a little later in the day than we thought we might have been because we had other issues. Some of the gear that we were carrying didn't hold up to the 5,000 mile test. At least, I don't know, it was probably more than that miles across the country to get to where we are now. So we had some failures of cables and things like that, but we've made it through. It's been a long week. I think the fatigue is starting to set in on me, but we're going to have one more dinner. We're going to get some sleep tonight, and we're going to fly to North Carolina in the morning. But we certainly appreciate it. Remember, all of these videos are going to be housed on Facebook and YouTube and at WeinigHolz-Her.com. Also, you can check back for some of the behind-the-scenes things that we did. We shot a lot of live footage on Instagram, Weinig_USA. On Instagram, we had a lot of that going on. We'll probably continue doing that as we go home even. But yeah, so it was quite the undertaking. We knew it would be, and it's been as big a deal as we thought it would be, if not more. But yeah, so it's been a great time. Brett, why don't you give us your thoughts? You did a little traveling this week.
Yeah,
again, it was been 5 days and, 6 days considering we left on the Sunday to get to Miami, but it was definitely an adventure. And honestly, it's gone by really, really quick. Yeah. It feels like just yesterday we were getting a meeting in Charlotte at the airport to get on that plane. Yep. Got to bring in Mr. Spedberg, the brains behind the whole all the technology and getting us streaming and getting us online and making this all happen. So it's been fantastic. But I really appreciate everybody's efforts, all the dealers that we went to see, all the customers that came out, all the technicians that put in the extra time and the hard work, and all the sales team that got out and helped all the customers that were coming in, and all the people that made this happen. So we thank you very much for all your efforts. And Christian, I think you did a fantastic job, and hopefully you don't leave us and get into film production. We still want to keep you as the marketing guy.
I think we're safe.
But I mean, if you think about it, guys, what was it? About 3 months ago, we started doing these types of things with a handheld cell phone. And now we've got a rig that we carry with us, and online and live and more professional. So again, it's been a big learning curve, steep learning curve, and I think it's gone off very, very well. So Christian, any last words?
So I'll echo Brett and Andy. A huge thank you to everyone involved this week with the Retool Tour. My 2 cents in all of this is that we need to adapt in new technology. I think that's at the heart of the Weinig Group, and I also think that is at the heart of what we are currently doing to bring our message to you. So I think that there is just a really, healthy balance there between our machines and the way we bring our technology, our machines to you, the audience. So again, it was great. Thank you so much for watching. If you guys have any kind of questions, put them in the comments field. We'll get to them. We're going to keep putting out videos throughout the next month or two. Sometimes we'll be shooting on Tuesday mornings, I think, Andy, right? Yeah, okay. So we'll continue our TCA addresses in Mooresville, or other places. But as far as this week goes, that's a wrap.
Yeah, so before we cut, follow us on Instagram on the way home. Be back on watching us Tuesday morning at 9 a.m. Eastern Standard Time for the TCA. We'll give you a lot more information. Once our minds are clear and we've had some sleep, we'll tell you a little more about all the things that happened this week. So thanks a lot. Have a great weekend.